Okay, I have the two new cells under a brake drum, a brick and a 5mm plate. I'm going to hold them under compression until they dry, just to see if that does a bit better job. I'm back testing out the new mix for the cement binder. So for the positive side we have 3 grams of graphite, 1 gram of nickel hydroxide, 4 grams of carbon, 3 grams of cement and 5 grams of water this time. Reduced it by 1 gram from the previous test, and 3 drops to add a bit extra so I could mix it a bit easier. This 5 grams for all of this allows it to be compressed. So for the negative one here, they're much thinner. Have a piece of stainless 316 through there. My soldering's a bit dodgy. This is the negative one. I marked it with that blue thing. Bit of staining there, don't know what from. Could be out of the carbon. The negative one's all graphite, so it's got carbons and graphite. It's got 3 grams of graphite, 5 grams carbon, 3 cement, and 5 grams of water plus the 3 extra drops. Positive one's same thickness. Not too bad. For resistance, I've got it connected up through that, the multimeter. Just holding it on here. So we've increased our, lowered our resistance quite good, but it's much thinner cell. So that's 7.1 for the negative side, and for the positive side, eight. Not too bad considering it's got 1 gram of nickel hydroxide, which is not conductive really at all. Oh, you can't measure it on what I have here. I'm pretty sure it's just like mud. So I think you need to compress it tightly. Hopefully the soldering stays. It's a bit hard soldering to stainless wire mesh. We used the stainless wire as well. That took the solder well, but this was hard. So we'll set it up and get it ready. Okay, the cells are bubbling like crazy. If you can hear it. Alright, I'll connect the leads and get back. Okay, back. Connected the cell to the data logger. We're at 0.1 volts. So first charge, trying 2.2 volts. Set the monitoring, connecting charge. Okay, so it's 600 milliamps. That's not too bad for the cell. For starters, so we'll give it a charge up. It's the first time it's been put in an electrolyte, so it may need 24 hours or longer. So let's hope the stainless steel mesh holds up and the carbon stays bonded to each plate. I'll get back. First charge for the cell, 2-hour charge time. Test, 20 milliamp load, starting now. First discharge of the cell, 51 milliamp hours, 42 milliwatt hours. Average voltage 0.83. 2 hours and 32 minutes. Okay, it's the second day. Cell's been in electrolyte overnight. It's just had a charge for 2 hours and 13 minutes. It did take an amp and then slowly worked its way down to about, what's that, 200 milliamps, starting 20 milliamps now. I think the cell's still intact. I can see the positive one on the top of the negative one. Now it looks like it's all there. Not a bad second run on the cell, still holding up. It's 53 milliamp hours, 47 milliwatt hours. Average voltage is slightly up, 0.88. And runtime was 2 hours and 39 this time. Fourth run after a 2-hour charge, 30 milliamp load this time because it was getting late. 51 milliamp hours, 45 milliwatt hours. Average voltage 0.87, down by 0.01 of a volt, but a higher load. Okay, so the cell's made it to 13 charges, but we're only like 1 milliamp hour and 1 milliwatt hour after an hour and 20 minute charge. Sort of got to here, number 9, 38 milliamp hours, and sort of dropped. So something with the mesh inside the negative, because I swapped it over with a zinc plate and the cell came back okay for the first run and the second run. And the third run it failed, so I pulled the zinc plate out, left it out overnight, and it's on a low cutoff voltage. We're at 159 milliamp hours and 68 milliwatt hours, so its average voltage is only 0.43 and it's still at 0.3 volts. It's nearly 8 hours run time. So there's something odd that's running with the zinc plate. The other one's there. It seems to be intact still. Not sure if it's galvanic corrosion under the solder and the stainless wire, maybe. But connecting the lead to here, no difference. I've had a alligator clip here with the wire connected also to here, and still not so good. It's got a silver looking colour, so I'm not sure if it's actually plated with zinc there or that's the colour of the cement. That's where I scraped it with the probe, see that line? So very strange behaviour. Good on low voltage, but you just have to pair them up with lots of them. Alright, the cell's been charged up. The positive side is now attached to a graphite, a piece of plastic, and it has a graphite pad as the contact for the alligator clip. And it's the original cement binded negative cell. So as you can see, the voltages, the graphite actually is good, but not good, and it's expensive, and it does still suffer from that ripping at the electrolyte boundary. But with heavy charge, you could probably less your charge maybe. I want to sort of overcharge them to see how long we can get out of it. So graphite plays a part in the cell, actually, for a better benefit, but it's very expensive. A piece of that think 2 of them is $30. And it's brittle, look. See how it goes anyway. Test of the cell with the positive plate and a zinc plate. Had a 5-hour charge. It's been running for 11 hours now. Seems to be holding 0.2 volts. I've put it down to cut-off voltage is 0.2. So we're at 221 milliamp hours, 81 milliwatt hours. It sort of drops off down to here about 0.4 and it runs for many hours at 0.4. So if you build the cell, you could make 4 cells and you probably get 1.6 volts or something at that power rating. Milliwatt hours would be up because the voltage wouldn't be dropping. So we're going to stop it now. So we're at 221 milliamp hours, 81 milliwatt hours. Okay, back with the results from this run. Not so good, looked really good at the start. That was using the mesh as a collector inside the carbon mix. Not sure if this is 316. The magnet doesn't stick to it, but even the group of magnets. And it sort of broke along the electrolyte level. And I've substituted the negative plate for zinc plate. Slight improvements. I ran this one to 0.2 of a volt, went for 7 hours and 59 minutes with 68 milliwatt hours and 160 milliamp hours. But if you do that and run it down to 0.2 volts, your zinc plate will end up like this. It doesn't know, it played it on a charge, but it decided to consume it near the top of the electrolyte. And I reckon you can see the zinc floating on the top there. And then it finally, these ones here are with the carbon pad, the positive one, connected to graphite. So we sort of went up again, but we started dropping. Put a zinc plate back in and got another good run, 134 milliamp hours, but at 0.2 volts. So not that impressed with the cell. Yeah, I thought I'd buy some 316 here, but this here stuff, turns out the magnet stuck to the washing machine, didn't it? Oh great. Got it. It sticks. Look, you can't even buy anything on eBay like this, metals. This piece I found, it's a larger, it's thicker, is 316. Magnet doesn't stick to that one, so I might have to make it out of this stuff. So I'm not sure if I'll have to drill the holes bigger. The carbon may stick through there and bond, but I'm going to be 2 weeks off if I make it this week. I do have this one made and ready to go, so but it's not 316, so we're probably just going to have the same end up product as this. But yeah, well, I really don't buy stuff like this on eBay because they're just all lies. It's all just lies. So enjoy the video. I'll catch you on the next run. Let's hope the next one. No, I'm going to test that one first and then we'll do this one. and one of these may work. So thanks for watching, thumbs up, and have a good day. So the reason I want 316, because that wire around there is 316 grade, marine grade, and as you can see it's not corroded, that's just got plating around it. This cell's been in potassium hydroxide mix for over 3.5 years to 4 years. And if you can see, that piece which isn't plated is still clean and contacting. All the rest has just got nickel coating probably. There's another shiny piece-ish. And that cell still works. Does it 3 hours at 100 milliamps. But I broke the center core now, so I can't test it anymore. That's why it's sitting here. Actually, the glass jar broke not recently, which was holding the potassium hydroxide. So it took like 3.5 years to break through the glass. Thing I forgot to say, the negative one didn't dissolve away. So negative side unaffected so far.